Children, next let's discuss the third case, that is whenever a particle enters at an arbitrary angle theta to the magnetic field. Okay, so whenever the particle enters at any arbitrary angle theta to the magnetic field. Here look at the motion of the charged particle. Here this is the path of the charged particle. It is neither parallel to the magnetic field and it is neither perpendicular to the magnetic field. It is entering into the magnetic field at an arbitrary angle, and this is that angle. So this is the magnetic field. Okay, this is the direction of magnetic field and it is entering into the magnetic field at an arbitrary angle theta. So here we need to resolve our velocity into two components. Then only we will be able to find out the path of the particle in this case. So for that we need to resolve our velocity into two components. So this is our velocity vector, and how will you resolve a vector? Do you remember? One is the perpendicular component and another one parallel component. Okay, so this is our parallel component and this is our perpendicular component of the velocity, and this parallel component is adjacent to theta. So let this be our v cos theta, and this is the perpendicular component, so this be our v sin theta. So we have resolved our velocity vector into v cos theta and v sin theta. And as you can see in this figure, our v cos theta is parallel to the magnetic field, right? Magnetic field is acting along this direction. V cos theta is also along the same direction. So what is the angle between v cos theta and magnetic field B? Yes. So the angle between v cos theta and magnetic field B will be 0 because it is entering, because it is parallel to the magnetic field. Now, for this component, what will be the force? What will be the force due to this parallel component? So force F is equal to Q into our component is V cross B. Okay, V cross B, and here we need to here V cos theta, it is parallel to B. So the angle between them, theta, will be 0. Now what is the force? Force is QVB, right? So here Q into V is V cos theta. So V cos theta into B. And what is theta in this case? Theta is 0. So our force will be 0. So along this direction, the particle will experience a 0 force. 0 force means 0 acceleration. 0 acceleration means constant velocity. So it will move undeflected. Okay, so along this direction, the particle experience a 0 force, 0 acceleration, but at the same time the path will be undeviated. So it will experience it will follow a linear path along this direction. Now what is the case of this component v sin theta? Okay. Now children, in the case of v sin theta, this v sin theta is perpendicular to the magnetic field B. So what is the angle between them? It is 90 degree. And what is the force? Force F is equal to Q V sin theta, because now our component is V sin theta. V sin theta into B. And we know the sin theta is sin 90. Sin 90 is 1. So we will get the force F is equal to QVB. And at the same time, we had already studied in the previous session, that is whenever the particle enters perpendicular to the magnetic field, it will experience a circular motion. So in the perpendicular direction, the particle experiences a circular motion, but in the parallel direction, the particle will follow a linear path. So what will be the path of this charged particle? There is a confusion, right? The path of the the particle will be a combination of both these types of motion. That means at the same time the particle must execute a circular motion and at the same time translatory motion or linear motion. So the particle will move like this. The particle executes a helical path. Helical path. Okay. This is our helical path. See, it is executing a circular motion. At the same time, it is executing a linear motion. So, what is the path of the particle? It's a helical path whenever the particle enters in a magnetic field at an arbitrary angle, especially acute angle. So, this is an acute angle. Okay, children? Children, so what is the radius of this helix? It will execute a circular path. So what is the radius of this helix? Again, the same procedure, magnetic forces balanced by the centrifugal force. So what is the magnetic force? It is Q V sin theta into B, because which component is responsible for circular motion? V sin theta. So we should consider V sin theta here. V sin theta into B equal to centrifugal force. What is the equation? mv square by r. Here we should consider v sin theta. So mv sin theta whole square by r. Again v sin theta and 1 v sin theta will cancel. Then what is radius? Therefore radius r is equal to mv sin theta by qb. So this is the radius of that helix. Children, next let's discuss about the frequency of this helix. Frequency means what? How many rotations are completed by the charged particle in 1 second. That is the frequency. So here for that we need to consider this equation V equal to R omega. You had studied this equation in your +1 course. V velocity V equal to R omega. Omega is the angular velocity. Now therefore omega is equal to V by R. And here which V? Circular motion is due to V sin theta. So instead of V, we need to substitute V sin theta divided by R. So what is the radius of the helix? In the previous session, we had just completed that derivation. Radius of that helix is mv sin theta by qb. So just substitute mv sin theta by qb. Now this V sin theta and V sin theta will cancel. And what is left? We have 1 by m by qb. So therefore omega is equal to qb by m. And we know omega is equal to 2 pi nu. And we need to find out this nu. So what is this nu? Nu is equal to omega by 2 pi. Nu is frequency and that is omega by 2 pi. So therefore nu is equal to omega. What is omega? Omega is qb by m. And in the denominator we have 2 pi. So expression for our frequency is qb by 2 pi m. You should remember this frequency, study this expression by heart. Okay. So frequency nu is equal to qb by 2 pi m. And if you get frequency, once you get frequency, you can easily find out the time period. What is time period? Time period is the reciprocal of frequency. And again, what is the definition? It is the time taken to complete one rotation. And it is 1 by nu. Take the reciprocal of this expression. So you will get 2 pi m by qb. This is the time period of that helix and this is the frequency of that helical path. Okay. Children, next let's discuss about the pitch of this charged particle in the magnetic field. So what do you mean by pitch? In +1 course you had done that practicals, vernier calipers, screw gauge. There you had studied about pitch. And what is pitch? It is the distance moved in one rotation. So there is another equation for distance. What is that? In terms of velocity, we can write distance is velocity into time. Since pitch is equivalent to distance, we can also write pitch is equal to velocity into time. And here, which component of velocity is responsible for the linear motion? The particle is moving along this path due to which component? Due to v cos theta. Because which velocity is acting along this way? This is v cos theta. So this v cos theta is responsible for the linear motion. And here in this case, we should substitute v cos theta into time. Time is the time period. And Previously we had derived the expression for time period. What is that? 2 pi m by qb. So just substitute that expression here. You will get the expression for pitch. So what is pitch? Pitch P is equal to V cos theta into 2 pi m by qb. Okay, so we had derived radius of helix, frequency of helix, time period of helix and pitch of that helix. All the four quantities are very, very important and you must study, you must by heart the equations, you must also study to derive all these expressions. Okay children.